Alright, here we have the notes for section 1.6, which deals with two-dimensional figures. So here's our main ideas in vocab. So main ideas: identify and name polygons and find perimeter or circumference, and that should be area of two-dimensional figures. Alright, so definition first. So a polygon is a closed figure whose sides are all segments. The sides of each angle in a polygon are called the sides, and the vertex of each angle is the vertex of the polygon. So the angle and polygon terminology are the same. So it's a closed figure formed by a finite number of coplanar segments, so that the sides have a common endpoint, are non-collinear, so they don't lie on the same line, and each side intersects exactly two other sides, but only at their endpoints. And then you name a polygon by the letters of its vertices written in consecutive order. So if you're going clockwise, you just name them as you go around. So key concepts here. So these are examples here of polygons. So each side connects to two other sides, but only at their endpoints. So here you have some non-examples. So this guy isn't closed. This one doesn't have line segments. It has some curves. And this one, the lines cross each other, so this is a case where they intersect, but not at the endpoints. So a couple other definitions here. So you have concave and convex. So if you have a polygon and you extend the edges, if any of those extensions go into the shape, it is called concave, otherwise it's convex. So like here, this one would be a concave shape, because if I extend xy, it goes into the shape. This one and that one would be convex, because if I extend any of the segments here that make up the edges, none of them pass into the interior. So that's the difference between concave and convex. Oops. Okay, so normally polygons are classified and named by the number of sides they have. In generic terms, if you have a number n sides, it's called an n-gon. And then you have what's called a regular polygon, which occurs if your polygon is convex and all the sides are the same length. So remember, convex means that no extensions go into the point. And over here you have the names of some common polygons. So 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, hex, hept, oct, non, dec, and dodec for those shapes. Now, quadrilateral is a very vague term, like squares, rectangles. Those are both examples of quadrilaterals, a parallelogram. They all have 4 sides. So this doesn't tell you anything else about the shape other than it has 4 sides. Alright, so example 1 here, name each polygon by its number of sides, then classify it as concave or convex, and regular and irregular. So we'll do A here first, so it has 1, 2, 3, 4, 5. So this is a pentagon. It is convex because if I extend any segment, it never crosses into the inside, and all the sides are congruent, so it is also regular. This guy over here has 1, 2, 3, 4, 5, 6, 7, 8, so it is an octagon, and it is concave, because if I extend any segment, it passes like this guy here. If I extend it, it goes into the inside. Same, any of them have 1 on one end, which means it is automatically irregular. No concave shape can be regular, so it has to be convex in order to be regular. So if anytime you see concave here, it's automatically irregular. Alright, just some definitions of perimeter and circumference. So the perimeter of a polygon is the sum of the lengths of all the sides. For a circle, that's called the circumference because it doesn't technically have sides, it's just the distance around the circle. The area is the number of square units needed to cover a circle, and here it gives you some equations for a common shape. So you have triangle, square, rectangle, and circle. For a circle, so circumference is 2 times pi times r, and area is pi r squared. Rectangles, length and width for L and W. For squares, S is side. For area of a triangle, it's base times height. Or for perimeter, B, C, and D are just the 3 sides. Okay, so example 2 here. Find the perimeter or circumference and the area of each figure. So for this rectangle, this guy is also 2.1. This guy is also 3.2. So the perimeter for a rectangle is 2 lengths plus 2 widths. So that's 2 times 2.1 plus 2 times 3.2. So that's 4.2 plus 6.4, which is 10.6 for the perimeter. For the area is length times width, so 2.1 times 3.2. And if I grab my handy calculator, 2.1 times 3.2, that is 6.7 for the area. So here that would be centimeters, and area is in units squared, so centimeters squared. So for this guy, it's a circle, so the circumference is 2 times pi times r, so 2 times 3.14, and the radius is 3. Your calculator does have a pi key on it. You're free to use that one if you want. So inches, area is pi r squared, so 3.14 times 3 squared gives you an area of 28.3 inches squared. Alright, and lastly here, so in this case they don't actually give you the shape, you have to figure it out yourself. So you have some triangle that has vertices at P, Q, and R, one's the perimeter and one's the area. So over here on the side, we'll see if I can draw my triangle. So at -1, 3, so there is P, -3, -1, there is Q, and R is at 4, -1, so P, Q, R. So that is my shape. So to do the perimeter, I need the lengths of those 3 sides, so I need to find 3 distances, and the area is a little bit more straightforward to do. So I need to figure out what QP is, I need to figure out what PR is, I need to figure out what QR is. QR is actually the easiest one to do. It's just a straight line. It is runs from -3, -1 to 4, -1, so that's 1, 2, 3, 4, 5, 6, 7 units long. So I just need to figure out QP. So QP is going to be -3 plus 1 squared plus -1 minus 3 squared. So do that real quick. So that's -3 plus 1 squared plus -1 minus 3 squared. So that's about 4.5. So for PR, it's going to be -1 minus 4 squared. I'm off the bottom of the page, sorry. Plus 3 plus 1 squared, which is 5, I think. Let's figure out. I don't think it's actually 5. -1 minus 4 squared. So I checked my math. That's not 5. That is 6.4. So the perimeter is 4.5 plus 6.4 plus 7. So 4.5 plus 6.4 plus 7 gives me a perimeter of about 17.9. So to do the area, that's a little bit simple. So area is 1/2 base times height. So I can actually just count this. I actually know the base. The base is QR. So here, the area is 1/2 times 7, but I need the height. I can count that though, because that's from QR up to P. So that's 1, 2, 3, 4. So 4 would go there. So 1/2 times 7 times 4 is going to be, so 1/2 times 7 times 4 is going to be 14. Would be your area. And that's the end of the section.